And happy Sunday. It is Sunday, October 8th, 2023, if you're a time traveler. This is PFG Live. Good morning, everyone. What a beautiful morning here in the Northeast. The rain is gone. The sun is out. The temperatures are starting to get crisp. And Joel L. checks in, only 91 degrees in Chandler, Arizona. Welcome, Joel. Nice to hear from you. Right now, we're reporting 17 science, 5 science dew point, and that translates to 61 degrees Fahrenheit, severe clear. Hey, Rob, you've been saving that all week, haven't you? Rob Renz checks in from somewhere in Pennsylvania, 6.93% relative humidity. I'm proud of you. That's awesome. Robert Simpson is here. Good afternoon. 53 degrees Fahrenheit near Detroit, but not too near. Welcome. Let's see. Oh, Test Room 2003 says good evening from Oostkapelle, Netherlands. Am I getting even close to that correct pronunciation? 18.1 degrees Celsius and 83% relative humidity. Not bad. Carl Tauber is here. All rise. Be seated. Carl reports 61 degrees and sunny in the People's Republic of Rhode Island. Test Room says that I would not be arrested in the Netherlands if I pronounced it that way. Excellent. That was my goal. Evils reports 21 degrees centigrade. We'll alternate on that. 68% relative humidity in Ghent, Belgium, home of chocolate. That'll start a war right there. Well, nice to see everybody. Interesting week. The weather is just superb. I told my wife as I was having lunch earlier, I said, I think after the live, I'm going to go sit on the back porch and drool on myself. It's just one of those days. Just have to be outside. Friday, I spent, yesterday, it's all a blur. Yesterday, I stayed home and I got stones ground. And I got 9 sets of 6-inch stones ready to go this week. Some of them are heading out the door. Some of them heading for inventory. But I got a ton done. I was going to finish them today, and I decided, nope, I'm chilling out today, and we'll finish those tomorrow. So a lot of little stuff to report, and some successes. Rob Renz is having success controlling relative humidity in his AMS. That's awesome. I too had to go through my AMS on the Bamboo and change out my desiccant cylinders in several locations to get things back in shape. And that is also under control. So we're pretty happy in the relative humidity department in the 3D printing world. So let's see. I got a message earlier this week from somebody named, let's get his message up here, Philip in Warwick, New York. Philip is looking for some help, and if anybody could help him, let me know. He says, I have a motor control project using Arduino. I'm looking for someone to wire up the breadboard. I have all components and it's coded. And he gives me a phone number and reiterates that he's in Warwick, New York. If anybody wants to help out Philip, DM me and we'll hook you guys up. I have a very full plate right now, so I couldn't jump in on this, but I'm guessing he got a kit or something from someone and just needs help getting things wired up. So if anybody wants to help him out, let me know. That mission is accomplished. Earlier in the week, actually a couple of days ago, my son informed me that he and 2 of his friends, which he named, were working together on a project in the high school. Now, this project is called the Trebuchet project. So every year, the very magnificent physics teacher, Mr. Pat Kaplow, has a program where the kids build trebuchets, and they do it in teams, and the teams can't have more than 3 people. And they don't have a lot of time. It's actually pretty amazing. I think they have 6 weeks, maybe, to build and be ready to fire on Trebuchet Day. So they build these trebuchets. They have a limitation on the design. The principal limitation is the length of the throwing arm cannot exceed an amount. I think it's 1.75 meters. I might be wrong on that, but it's pretty impressive. And there's a lot of information online about trebuchets and building trebuchets and all that kind of stuff. And they get the kids to design from a white sheet of paper and build and demonstrate their trebuchets. Flat Lapper is here reporting 51 degrees and mostly cloudy in northern Illinois. And you're late. So I can't read that. Hang on a second. One of these days, somebody's going to show me how to fix this. Oh, coffee. Yeah, the coffee's on. Pour yourself a cup. It's in the back. So the way they do Trebuchet Day is phenomenal. In the middle of the athletic field, they literally build a castle out of these kind of divider walls. They do a round castle, and Mr. Kaplow dresses up as the king, and they have other people dress up. And the object is, from a circle surrounding this castle, you have to fire a projectile and get it into the castle. That's some number of points. If you hit the castle, it's some number of points. If you get it into the castle, that's some number of points. And then if you hit Mr. Kaplow, you get a lot of points. So, of course, Sam did this 5 years ago. So we still have remnants of the old trebuchets. But the kids are not allowed to reuse trebuchets. They have to build from their own design. So that started happening this week. So I'm sitting there and the 3 of them, Jared and his 2 buddies, start marching toward the shop. And I said, "What are you doing?" He says, "Is it okay if we scout out the shop for wood?" I'm like, "There's no wood in the shop. This is a metal shop and there's no wood." So they turned around and went back to what they were doing. And I went in and I explained to them, "Look, this is an engineering project. You need to have a preliminary design review, and then you're going to have a final design review, and then you're going to build. So you got to prepare for a preliminary design review." So off they went. And sometime later, I'm again sitting in my easy chair or something. I don't remember where I was. And Jared comes over and says, "Okay, we're ready for a preliminary design review." So he whips out these 2 sketches, and they were sketches of what they planned on doing. And I looked at a couple of the numbers that they put on there, and I immediately pointed out, well, this is not the length of the throwing arm that you were supposed to maximize. And they were like, "Oh, that's right." So, that's what design reviews are for. So they went back around. Anyway, long story short, that process is underway, and it'll be pretty funny to enjoy their results. They have to launch a water balloon that's about the size of a softball. I'm not sure if I think it's 1 kilogram. Cannot exceed 1 kilogram. So, filling the water balloons, weighing the water balloons, all that kind of stuff is part of the process. So that's the story on local engineering here, and the PDR from Jared. Meantime, I'll give you my weather report. This is actually coming from Manchester Airport in Manchester, New Hampshire. Let's see. This was as of 17:53 Zulu. Winds are 250 at 7 knots. Visibility 10 miles. Sky is broken at 4,500. Temperature 17. Dew point 0.05. Altimeter 2952. Wes is here. Hey, Wes says it's 67 Fahrenheit and sunny in rural Idaho. Excellent. Where the potatoes get along with the onions as it should be. So, I broke a tool. I'm sad about it because I liked this tool. And I'm responding by ordering 2 more of them. And I don't mean a cutting tool. I mean a tool. So you may recall in the videos I did on modifying the tool post on the TL1, you saw a little boring head. It was a Criterion 1.5-inch boring head. And I was using it to bore holes to some precision for pins. Well, this week I was using that very same boring head on a project in aluminum. And I'll talk a little bit more about that project. But in doing so, I was boring a hole that had a flat bottom, and I was on the Bridgeport, and somehow I managed, I'm still not sure exactly how, to stall the tool at the bottom of the hole, and the torque from the Bridgeport, it was in low gear, just snapped the tool. And if you ever looked at one of these boring tools, it's a dovetail set of ways and a little drive screw. And what happened was on the outer housing, where the dovetail has a flexure. Of course, it is the weak spot. That flexure just cracked the length of the tool, and I'm sort of bummed out. So I've identified a few of them on eBay. I will be getting another one, but it was one of those days. It did not screw up the project, which we're going to talk about in some more detail. Hey, look, K-Bonk is here saying it's chilly, 61 degrees in Philadelphia. Welcome, sir. Nice to see you. So we'll get back to that. You may have seen more jabber on the Discord server. If you're not on the Discord server and you want to be on the Discord server, may I recommend you just head over to the links page, and you will find a link to be invited to our Discord server. And the links page is pfg.gg/links. So I want to say a big thank you to Unix Carbide. So Ike has been tutoring us in the use of Git. He and Daniel DBX have been helping this hardware guy figure out how to write software and make it all work. So big thank you there. But also I had questions for the computer nerds, and I basically said, look, I want to learn Python, like learn it pretty well. How do I do it? And they recommended some books. So I want to just share with you what I got and my initial review. The first book that Ike strongly recommended is this one. It's called Python Crash Course, and it's by Eric Matthes, Matthes. And right now, actually, I was really surprised when I saw this. On the cover, it says over 1.5 million copies sold. This is made out of dead trees. It's nice to know that people are still using books. So I am, I guess, about 20% of the way into it. Maybe not quite. And it's great for somebody who has done a little bit of programming in BASIC and things like that. To be able to pick this up and actually understand it and start understanding the vagaries of Python is fantastic. So highly recommended. More to follow. Jeff Lawford has joined us. Late arrival from a gray, drizzly 40 degrees F in Alaska, taking a break from finding a squareness comparator and a cylinder square project. Excellent. Welcome aboard. Seeking squareness is always in order. Nice to hear from you. 40 degrees. We know what's coming. The second book that Ike recommended, and I think DBX concurred on, was this little book from O'Reilly called the Python Pocket Reference. And it is literally that. It's a small book. Oh, not finding, but grinding. So Jeff is grinding a squareness comparator and cylinder square. Excellent. That sounds like fun. Please continue. Continue in your squareness. So this little book is exactly what it sounds like. It's a reference book, but it's handy. And at this moment in my Python development, it's not quite in play. But this other book, Python Crash Course, is in play. So that's underway, and I'm learning slowly. But I managed to go from literally hacking stuff together to cleaning up code, making it do some things that it wasn't doing before. Let me, I can show you. Let's see. Oh, there it is. If you're watching on video, you are now enjoying some code. So this has actually been going quite nicely. And the advantage or the result of doing this is it is publishing my temperature and humidity data from one of these from all of these sensors up to the server called Notify. And Notify does a pretty cool thing. And I'll show you what that looks like. Boom. So this is the feed from my Notify topic. That's the term of art. And you can see that I'm getting reports from my various little feathers. So the last one is KP2. That's the one on the windowsill. Relative humidity indoors, 53%, temperature 75, and battery 94.7%. This has been running for 5 days on a single LiPo 2000 milliamp hour battery. This bodes well. So this is doing a report every hour. We had started this a couple of weeks ago, and we had several crashes in that if it tried to pull time from the time server and it didn't get it, or it couldn't connect to the time server, it would cause a crash. So part of what I was doing in improving the code was putting in error trapping. So if you tried to do something and there was an error, it had something to go do rather than just crash. So far, this software has been running for 5 days, and it's used, let's just say it's used about 5% of battery according to the onboard battery controller. If you extrapolate that out, that's 100 days of operation, which is pretty cool. I don't think we're done optimizing the current requirements, but so far so good. So much was learned, and I will be reporting this to the group as we move along. So that's the current status of the sensor project. Very impressed with the hardware, and we're up to 4 of our little workstations now, which you have seen. These little 3D printed easels. So inexpensive. 2 of them are currently running the long-term test, and 2 of them are sitting on the desk now, literally having arrived or been put together this morning. So that's the update on on that and what's been going on in that department. Let's see. Oh, I told you about the boring tool explosion. So I should be getting another Criterion 1.5 inch in the next week or two. This is a minor thing I wanted to bring up, but on the website we added under the merch section, we added heavyweight t-shirts. I'm actually wearing one right now. When we originally put the t-shirts on the website, they were these lightweight t-shirts, which frankly I'm not a big fan of. And then later we figured out that the company that we were using, called Printful, had these nice Gildan heavyweight shirts, and we put them on the website, and I finally ordered a couple for me, and I'm reporting to you that I really like them. These are my favorite fabric, and it is a cotton t-shirt. In fact, it's 90% cotton, 10% polyester. Made in Nicaragua, in case you're wondering. And there you go. That's what the labels look like. So if you want a t-shirt and you like the heavyweight ones, go get them. We make a couple of bucks from that, but nothing serious. Let's see. What else? A brief report. Last Thursday, we had the first event. What format? So the battery is not the cylindrical battery, K-Bonk. This is the flat pack, one of these flat batteries, these flat LiPos. The one that I'm showing on camera right now is a 1200 milliamp hour, but the one that's doing the long-term test that I just reported on is a 2000 milliamp hour. Now, K-Bonk is asking because we had talked about this other cylindrical LiPo battery called an 18650, which is an 18 millimeter diameter, 65 millimeter length, and they're in this characteristic blue color. I got those. We're going to be experimenting with those. Those are 3,500 milliamp hours. So I do have them. I just got connectors in this week, so I'm going to be firing up one of those as an experiment. But no, we have not yet switched over to those batteries. So the goal here is basically see how long we can go in a small package doing relatively infrequent measurements and posting that information over the network. The goal is to have an inexpensive sensor we could put everywhere to measure everything and have it report in. So far, so good. Oh, the connectors. So I went to the Adafruit site, and they have battery side connectors and pigtails. It's these little, I don't remember what the name of the connector is, but you see the wire coming out of the battery, and it goes to this little white connector on the bottom of the feather board, and they have those in pigtails. Flatlapper says, real 18650s are great batteries. I have 15 or so with hundreds of cycles. Yeah, so we're working our way there, and they're not expensive. These are not expensive batteries, but they, I think the EV market is also helping push that technology so that it's very efficient and very dense, very high energy density. So we'll report back on that. So this way we could monitor in real time not only temperature and humidity, but any one of a number of other sensors that are available that plug right in. Okay, so K-Bonk is recommending battery hookup. Robert Simpson says try to float it from 30% to 80% for best life. It's funny you mentioned that because that's exactly what I do with the truck. Although I go to 90%. Yeah, we'll see what happens. I did get this super fancy charger for these cells, standalone charger, and I think it's capable of doing that stuff, but we'll cross that bridge when we come to it. Very pleased with that whole project It's going nicely. Let's see. One of them just took a reading. Oh, KP3 just took a reading. Look at that. It's reporting battery at 102%, whatever that means. So last Thursday, we had the first antenna reception on the Discord server, which was a roundtable discussion that I invited everybody to about antennas, because as you may or may not know, that's my professional gig. Is I'm an antenna consultant of some 25 years, and we just opened up the floor to discussion. I don't think we had much of an agenda, and it was fantastic. I think there was about 6 people in the roundtable and asking good questions, and we had a good time. And it was wonderful. So this was mostly instigated by one of our contributors. WR Rocket is his handle. He's up in Alaska. Actually, at the time, he wasn't up in Alaska. He was down, I think he said Indiana, but he was on business. He is from Kodiak. And he had some antenna questions. I said, sure, let's just all get together. Carl checked in. He says, great antenna discussion. He learned a lot. It was a lot of fun. It was a hoot. So we're going to make that a regular thing. I think that Thursday night slot is going to pretty much stay the way it was. I think it was Thursday at 8. Can you confirm, Carl? Was it 8 o'clock that we started? And we went about 2 hours, which was surprising, but there were a lot of questions and a lot of stories. We did not record it, and that was intentional. I didn't want anybody to go to jail. So we're scheduled to do it again. I posted about this. I don't want to get the date wrong. I don't have my calendar up, but I will just watch for a post. It will be 2 weeks from last Thursday. Will be the next antenna reception, which was so named by Evils in Belgium. And the next antenna reception is 2 weeks from this past Thursday. So come join us if you want to ask questions about antennas, learn about antennas, or have some snarky comments about antennas. Yeah, it was 8 p.m. Thank you, Carl. So that's coming. So let's see. What else is cooking on the short list here? One other weird thing that happened this week was the shop computer started acting up. And by acting up, I mean I went to do an update. So Apple pushed out an update, and it said, hey, macOS needs an update. And I'm like, sure, go ahead and do an update. And after, thank you, Carl. Carl says October 19th, 8 p.m. for the next antenna reception. So I start this update, and the computer comes back and says, you do not have enough disk space to do this update. And I'm like, that's kind of weird, because the shop computer doesn't have a ton of stuff on it. So I go and I look, and I realize, yeah, there's a very small disk in that computer. I'm like, that doesn't make sense to me. And then after a while of debugging, light dawned on Marblehead. So if you are an Apple user, you'll appreciate this. The computer is an Apple iMac of like 2015 vintage. At the time, they were offering a large disk drive with a smaller solid-state drive in front of it. It all acted like one drive, but the small drive would act like a cache, and therefore it would improve the speed of access to your files. Great. So that computer actually had a 1 terabyte drive with it might be a 2 terabyte drive. Yeah, I think it was a 2 terabyte drive with about 128 gigabyte solid state drive acting like a cache. Well, a few months ago, that computer crashed, like died. And I was like, oh, I wonder if I could recover it. So I was able to bring it into recovery mode, reload the operating system, reinstall it, update the operating system as much as I was able to do, and then start reinstalling my softwares like Fusion 360, not a lot of things, but Fusion 360, Signal, one or two other things, and I was back up and running. Here's what happened. This was really bizarre. The spinning disk crashed like gonzo, okay? The solid state drive was still there. So when I recovered this computer, it said, hey, I have this solid state drive, and that's all it had, and I've been running on a 128 gigabyte solid state drive now for months on this computer. And I didn't realize there was a problem until I went to update it, and it said, you don't have any disk space. Well, it's right. I don't have any disk space. So I'm not sure what I'm going to do. The choices are do nothing and not be able to update. Another choice is to replace the spinny drive and recover the system back to how it was intended to be, which I believe I know how to do. And the third option is to punt, recycle this 2015 iMac, and get one of these small Windows machines and a standalone screen and Windows. So I'm leaning toward switching to Windows on that installation and taking this to recycling. It's kind of a bummer because the hardware, meaning the screen, the housing, I know Tuck's Garage is going to be laughing because he was showing me, Tucker was showing me earlier this recycled housing from an old Mac standalone computer that he was using the aluminum from for a project, which I thought was great. But anyway, I might just recycle this thing, but the screen is beautiful and the screen works great. And there's nothing wrong with this 24-inch screen, yet I don't really have a good way to keep using it. So I'm sort of bummed. And I'm sort of being pushed in the direction of not using all-in-ones anymore. Like having a separate screen and a separate processor is a good idea because you could replace the processor and you don't have to keep replacing the screen. So details to follow. Interested to hear your opinions, either here in chat or send me a message on any of the numerous channels. But that hit me. Actually, that was yesterday. It was literally yesterday I figured all this out. It was a very weird realization that the so-called Fusion disk, which is what Apple called it, had failed in a most interesting way. So that was while grinding yesterday. The shop computer just decided to remind me that I didn't know everything about computers. Robert Simpson says the newest Mac OS doesn't support non-M1 in the newest release, so your old one is EOL. End of life. Yeah, I'm bummed, but I think you're right. And I think I do have a screen in the basement that's not in use that will become the screen in the shop, and I'm just going to get another one of these computers that is the size of a ham sandwich. And I actually bought one for the ham radio station, ironically, and that is what's downstairs running the ham radio station. So it looks like another one is in my future, and we will continue with Windows in that application. So both of my offspring have been doing projects where I have taught them to use Cardboardaided Design. Robert Simpson says, we replace Macs every 3 years at work. Updates are a challenge. Yeah, a 3-year update cycle is not a terrible thing. And in fact, on my simulation computer, before we launch into the next topic, let me put the bow on this. I have a simulation computer that I use for antenna design, and its job is very simple: be the most powerful computer I could possibly put together without, selling my kids, for my professional applications. And you guys have never seen it. We've never shown anything from it. And it is a pretty powerful machine. And it has a big GPU in it and just a ton of memory, fast process. I mean, it's a bleeding edge machine. And my philosophy was 24 months. Every 24 months, I reevaluated my simulation computer and I did the appropriate thing. And in fact, we went through 2 of those cycles replacing the computer, and the company that I was working with is called Box Technologies, BOXX, down in Austin, Texas. And they did a great job building computers for me for simulation. And the last time that I went through that cycle looking to upgrade or replace my box computer, I realized that the industry had turned a corner, and it was no longer the computer that was important, it was the GPU. And I spent a pretty big chunk of coin and put a bleeding edge GPU in the computer, and I got a 5x speed up in my computations. 5x. Was that worth it? Oh, yes. So that went on for a while, and then finally it was time for another upgrade, and I ended up building a new computer. That's the one we have now, and putting in a yet another bleeding edge GPU. And don't ask me for the number because I do not remember. That computer lives in the basement because it puts out so much heat when it's doing simulations that my office was getting warm, and I have a air conditioner in the office, so it didn't make any sense anymore to have the air conditioner cooling the office while the computer was heating the office. So that computer actually lives in the basement, and we remote to it, and that's how that works. So anyway, I that's the story about that computer. So with all these computers, we have Fusion 360 and we have simulation software. We have all this stuff. I keep emphasizing the use of cardboard-aided design. So just 2 days ago, case in point. Well, let me back up even more. So Sam is doing this project in school in which a design for armor is being created. This is body armor. This is medieval armor. A design is being created and executed in the most artistic way possible out of metal. It's being fabricated. Sam is learning how to weld. I couldn't be happier. I'm so proud. But it starts with cardboard-aided design. So I get this picture from Sam, and it shows in scale, like at about, I don't know, about 1/6 scale, some of the armor pieces made out of white paper. So white paper cut up into shape, taped into the right shape, and that was pretty awesome. And then the next stage was slightly bigger scale. I think there was it might have been full scale cardboard, full scale cardboard modeling of these armor pieces. And this was brilliant. Now, it's brilliant for a couple of reasons. Number one, the cardboard is going to act in many ways like the metal. In other words, if you have to bend it, if you have to cut darts out of it and make seams and start welding, okay, in the case of cardboard, that takes place with duct tape or masking tape or whatever, or hot glue. But that whole project is starting to come together with cardboard. And when Jared came to me with the Trebuchet project, I said the same thing. And I heard him. This is kudos to him. This is before we had the cardboard-aided design discussion at all. I heard him in the other room, and he said to his buddies, "Hey, why don't we mock this up in small scale?" And to the credit of his teachers, they had done other little projects at scale with like little cars and stuff, and that was the first thing he thought of, is let's do a mock-up of the Trebuchet at scale. Brilliant idea. So does this make any sense professionally? Well, 3 days ago, I'm on the phone with my client. My client is in Utah, and he has a product that contains a couple of radios. It's essentially a consumer product, and we were dealing with some pretty esoteric technical issues about how these multiple radios were coexisting. And I said to him, why don't we replace this antenna, this embedded antenna, with another kind of antenna based on a circuit board that we could put over here in his plastic housing. There was a couple of features in this plastic housing that looked like it was a natural for holding a little circuit board. And I didn't want to change the plastics because that usually incurs a lot of cost. So he says, no, that could work. And we talked about that. I said, yeah. And the type of antenna I would put in there is a blah. And the reason is blah. And he thought that was a great idea. And I said, hang on a minute. And sitting at my desk, I picked up these scissors. And I picked up a 3x5 file card, as I am wont to do. And I started cutting up a prototype that was the right size to go into the housing. And then I took my pen and I started sketching a PC board pattern that would represent the antenna that I was proposing. And I dropped it into the physical housing that was of his that was sitting in front of me, and put the lid on it and kind of looked in the, peeked in it and basically said, yeah, this is going to work. And I practiced Cardboard-Aided Design, and it saved, I don't know how many go-arounds of trying to explain, of drawing a model, of coming up with a 3D model in Fusion or whatever. Or we're using SolidWorks on that project. And for the price of having a 3x5 file card handy and a pair of scissors. So this is a skill which I like seeing, and I want to see more of. We're surrounded by technology. We're surrounded by, my simulation computer. If it does not have 10 billion transistors in it, it doesn't have one. Yet, getting a human brain to wrap around a concept fast, there's no better way than Cardboard-Aided Design. John Saunders, amongst others, but I remember John using these words: fail fast, fail cheap. It's like there's nothing cheaper than a piece of cardboard for a mechanical design. So I would strongly encourage you to do a quick and dirty, cardboard mock-up of whatever the heck you're building, because many times you'll do that and all of a sudden your brain is going to say, hey, wait a minute. And whatever comes next is worth the price of admission. You want to get to, hey, wait a minute. And that's the goal. So that's the story on Cardboard-Aided Design. It was a huge win this week. And it has led to a new design that we're going to be executing. Sorry, I can't give you all the details, but you know how it goes. Okay, so I have another client. The funny story is, about 6 months ago, I get an email from a company not too far from me. And they said, we're doing this research project, and it has to do with antenna positioning. And would you be interested in helping us out? And it actually did sound really interesting, except for the fact that I was absolutely saturated. I had several projects already underway, and I could not take on another one. Certainly not in good conscience. So I said, no, I really can't, but you guys sound cool, and hopefully we could work in the future. So time passes. And of course, they were talking to Antennasis, my antenna company. So some months go by, and I get this email. And it's from the same guys, except it's not to Antennasis. It's to Kinetic Precision. And they said, hey, we have this antenna positioning project, and we need something ground very flat. And the mechanism that we have and that we've patented depends upon this very flat surface. And we're at the point where we need some help with that. And I just started laughing. I'm like, okay, universe, message received. I got to talk to these guys. So I went to talk to these guys, and they were awesome. And I am working with them now, at least on the Kinetic Precision side. So without getting into a lot of detail, they were taking a magnet, and they needed one surface of this magnet ground flat. And when I say flat, I mean basically optically flat. This just in from Jeff Lawford. He says, the RAM board, RAM board brand, heavy duty floor protector cardboard that contractors use works great for CAD, particularly large sheet metal prototypes. Thank you, Jeff. RAM board. Is that available at our favorite orange store? Interesting. Yeah, your cardboard thickness should scale with your project. That's pretty awesome. So these guys said, yeah, we need this magnet ground flat. I said, okay, so can you? So I went to visit them, and they gave me a pair of these magnets. Without getting into a lot of detail, these things are scary. They are so strong. And imagine a 1 inch diameter, 1 inch long cylinder, a squat little cylinder. And I believe these are neodymium magnets. The strength of this thing was absolutely scary. And I have to figure out how to hold this magnet and surface grind it. And that was really interesting. So after sleeping on it, not the magnet, but the idea, after sleeping on it for a while, I said, okay, here's what we're going to do. So the picture that appeared as the thumbnail for the video, for the notification of this video, was in fact me making that fixture. So I took a piece of aluminum, like a 3-inch by 1.5-inch bar of aluminum, probably around 7 inches long. And the idea is I will hold that vertically in a grinding vise, and at the top of it, I will create a well for this magnet and a clamp. And all the hardware associated with that clamp is going to be non-magnetic. So the screws, the washers are 3/16 stainless. Of course, the aluminum is non-magnetic. And then the choice of grinding wheels is pretty simple. It has to be a stone that's non-magnetic. And then I have to raise the shield. I have this this little shield that's intended to be as close to the work as possible, because it provides a way for the mist collector to suck up the mist. That has to be raised out of the way, because we don't want that passing over the very strong magnet. And that's where we're heading. So no results on that yet, but figuring out how to hold this very evil looking magnet was very challenging. And of course, PFG stones are part of the equation here. So after surface grinding, we'll hit it with the PFG stones, and then eventually we'll take optical flat measurements and observe how we're doing, and that's going to be the process that we need to deliver to the customer. But very fascinating problem, and I don't know if I've never heard of that problem coming up in any other situation, but here it is, and we're getting it done. So kind of funny, it's a crossing of all the streams at once. The PFG Stones, Kinetic Precision, and Antennasis all crossing at one point in New Hampshire. Go figure. So that was the weird grinding job. Now that was the job during which my little Criterion boring head exploded, and I'm bummed. So yeah, we need to get that back. But that's how I was making that well. In fact, I think I posted. I don't know if I posted it to Instagram. I definitely posted it to our Discord server. Probably the last seconds of its useful life were caught on video. Now it's in pieces downstairs. I'll take some pictures of it and I'll post it to Instagram. So there you go. I think you're pretty much up to date. I think we ran the list. If anybody has any questions, comments, or snide remarks, now is the time. You can post to our YouTube chat or our Discord chat, and we'll try to either address them or just make fun of them. I know Tuck's Garage has been listening and working in his shop today on the CNC machine. Flatlapper says, have you considered potting the magnet? I can't, because it goes into their structure and it has to be delivered back to them basically in the same standalone configuration. It goes into in their configuration, it goes into an aluminum structure, and then they do other things with it, which I'm not at liberty to discuss. But what would have been really cool, what I thought at first, see if you could find the flaw in this as I speak slowly. I thought, gee, if you gave me the magnet before it was charged, I can grind it before it becomes a magnet. And there's a flaw in that reasoning. See if you can come up with it. Jeff says, any health hazards to address with the neodymium dust? Would the dust retain some magnetism and stick to the ferrous metal in the area? So the good news is that it, like many neodymium, Tuck got it on the first go around. Correct, Tuck. Like all the neodymium magnets you've seen, like the little discs that we use to make, holders and stuff, that the thing you're looking at is not the magnet. It's not the neodymium. It's a nickel plating. So these do have a nickel plating on them, and I'm actually grinding the nickel. So from a grinding standpoint, it's a grinding nickel problem. After all is said and done, I think it's going to go okay. The PFG Stones, especially the carbide round PFG Stones, did a really super nice job of putting the finish on it. However, it's got enough of a divot. I say divot like it's an inch deep. It's got enough of a divot in it that it would take a very long time to do that by hand. So that's why we're going to do it by on the surface grinder and then finish it with the silicon carbide stone. Flatlapper said that is how we did all Alinco alloys. But did you do it before charging or did you do it after charging? So Alinco, I could see doing it before charging and then just charge the magnet. So Tuck says, distorts after charging? ? And the answer to that is, I'm afraid so. And not a lot, but since these guys are talking optical flatness, yeah, we can't do that. Rob Renz, I could hear the gears turning from here. Robin says, how thick is the nickel plating? I don't remember. It was remarkably thick. I don't have it in front of me. I'm sorry, bud. But it was definitely thicker than the distortion we're seeing. So I think we'll have enough. And it's not just nickel. Nothing's ever just nickel. There's a copper layer somewhere, and then a nickel plating. So by my calculations, we should be able to stay in the nickel on the outer plating, but I don't remember the number. Can I get back to you on that? Yes, Carl says the DC analog of magnetostriction. It's exactly that. This is weird science at this point. So what we're hoping is that I could do that grind, get that flat surface, and then it goes into their application. I believe it is glued in, so there's no big stresses that are put on the magnet after that point, and we'll keep that surface. But this is literally research. This is a research project, so we're not working with tons of history here. So a brand new 8-inch wheel will give us, some number of inches of separation from the head of the grinder, and I think it's going to work out. But the funny thing is, when you go to handle these things, you just have to think about every motion so you don't get near something metal. Yeah, so Rob Wren says, I think you may end up lapping them only with an aluminum lap. So we'll see. I think the stone's going to do it, because the preliminary investigation with the stone yielded a very nice surface. It needed to go deeper. So I think the stone will finish it. Aluminum lap was already considered as a possibility. But also, funny thing, I was in the initial investigation, Almost Machining had sent me a no, I don't want to get this mixed up. I think I got my guys mixed up. Anyway, I have a copper lap that was given to me, and I'll give credit for that another time, because I'm a little confused right now. But so I said, gee, I wonder if I could use this copper lap. So I took the copper lap and I took this magnet and I started rubbing it on the copper lap. And the damping, remember we talked about damping? The damping as you move across the copper lap was very significant. It's like there's no attraction to the copper, but as soon as you start moving it in a lapping motion, it felt like you were moving through molasses. It was hysterical. It really was quite funny. Carl corrected me. Alnico, not Alinco. Thank you. For aluminum, nickel, cobalt. I knew that, but Alinco sounds better. It's also the name of a alarm company that my dad did some work with way back. Flat Lapper says, my choice would be a high-pres copper composite lap. 110 is real grabby. Yeah, we'll see when we get there. First, I got to get to basically flat, and then we'll get to seriously flat. But there's definitely a little bit of material that has to come off. Not a ton, but we don't have a week to spend on each stone lapping them in. So we'll see what happens. I like the idea of using a non-magnetic lap and some diamonds. So we'll see how that goes. Yeah, so that was a story on that project this week. It's pretty interesting. And I'm learning things. And that's the most important part of the whole thing, is that we're learning stuff. If I get permission to post any pictures, I will. But I can't do it without permission. Okay. Any other comments, questions? Anybody want to see any particular topics covered in the future? While you're thinking about that, I'll remind you that a week from Thursday will be the next antenna reception on the Discord server. If you've never used Discord before, but you want to give it a shot, it's not that bad. If you have a high school student nearby, just grab them and they'll show you how to use Discord. And no, I'm not kidding. It's real easy. If you just click the link on the links page that says Discord invite, I think it'll walk you through installing Discord and getting on our server. So there you go. Okay. It's 3 o'clock. It's the top of the hour. We did it. And I want to thank everybody for being here. I appreciate you. I appreciate the opportunity to learn and share. The guys on the Discord server have been fantastic, especially with respect to this old dude learning software. And I appreciate it very much. So we'll see you guys next week. I don't see any impediments to next Sunday having a PFG.Live. The following Thursday will be an antenna reception. And we'll see you on all the usual channels. So from Windham, New Hampshire, this has been PFG Live. Take care.